Class.
Yeah.
That's super weak. Seriously, something's gotta do something. Do you guys want some coffee? Huh? Yeah? You want some coffee? Yeah? Want some candy? No? Okay. Alright, you guys are boring. It's boring class. Anyway, so page number is going to be 23. Thank you very much. And general multiplication rule for you people. So we have independent and dependent. So first thing I'm going to do is talk about the difference. So independent means one thing doesn't refer to the other. That's independent. Yeah? Okay, so this is an example of dependent. I'm going to pick 2 students out of this class. One after the other. Frederico, come on up here. So currently in this class, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20. Did I already count him? I don't know. Did I count him?
You can count him.
Okay, I'm not counting him. So let's just say there's 20 in here right now, okay? There's 20 students in this class. What was the probability of me picking Fred? 1 out of 20, right? Okay, there's 1 out of 20. That's the probability. Now, I'm going to pick another student, but Fred stays here. Fred stays here. So I'm going to pick, who should I pick? Come on up, Carlos. Now, what was the probability of picking him? 1 out of 19. Why is it 19 now?
Because there's less to choose from.
Less to choose from because I already have one sitting up here, right?
Mm-hmm.
So the probability of me eventually picking Smokey is getting bigger and bigger, right? Okay, so I keep out of the pool. If I keep wanting to choose Smokey and I'm just picking one at random, it's the chances to pick him get more. The more people I pick, because that makes the pool smaller. That is a dependent variable. Now, let's go back. So now, I'm going to pick another student. What's the probability of me picking Smokey?
1 out of 21, 20.
Just say there's 20 in there, okay? So it's 1 out of 20, right? There's 1 out of 20 chance for me to pick Smokey right now. So, and I'm going to pick one at random. Federico, come on up. So that was 1 out of 20, right? So that, we already said, is going to be the independent. Okay, now, I'm sorry, that was dependent. So watch this. Go sit back down. So now I'm picking another student. Now this is going to be my second pick now. What's the probability of me picking Smokey now this time? 1 out of 20 again. Why? Why? Did I put Fred back? Because Fred went back. So he's back in the pool. So it's still 1 out of 20. So that means every single time I select, it's going to be independent. It's not going to have anything to do with my previous pick. That's what independent means. Dependent means if I pick one and don't put it back. So it's going to be dependent on what I picked first. That's what dependent means. Okay? So that's A and B being independent of each other. So, and dependent, use formulas. So I have those here, which are going to go on your notas. Right here, right? There we go. If A and B are independent, we use A and B. You don't have this one? Oh, okay. Sorry.
that somebody doubled up on paper.
I know. Dang it, Fred.
I didn't do that.
Mm-hmm. Are you struggling there, Federico? Alright, I'm gonna write it on my sheet now. So P of A and B. And dependent would be my P of A and B, ABA. There we go. All right, with that bar B, bar A, the line going straight down. Okay, those ones right there, if you remember, that's what we did on Thursday. That has to do what we have remaining in that category. Now, let's take a look. So, for this example, it says Mr. C needs help with a science demonstration for his class of 18 girls, 12 boys. He randomly chooses 2 students to come to the front room. What's the probability that both students are girls? So is this going to be dependent or independent?
Dependent.
It's going to be dependent, right? So he's not going to put the one girl back, right? So just like when I was picking 2 students, I got 2 and that lowered my pool, right? So the first one would be what? Out of 8. Out of how much?
7.
How many girls are there?
18.
There's 18 girls, right? 18 out of how many?
30.
30. There we go. So the first one's going to be 18 out of 30 because there's 30 total, right? Okay. There's 30 total and we had 18 to start off with. Now the probability of getting another girl. So that means the first pick happened to be a girl, right? And so the second pick would be what? 29. Because I'm reducing the total number in the pool there. I'm reducing the number in the pool. Make sure I move this over. There we go. So, do you have your calculators with you? Okay. So, I'm asking you people to do some calculating with your calculators. And actually plugging it into the calculator is a good exercise because a lot of people struggle with using the calculator. bless you, I think.
Thank you.
All right. What did we come up with?
0.35.
Point 3.352. So that is a decimal answer, right? That's a decimal answer. As a percent, if I were to say what's the percent, you would tell me 35.2%. Is that pretty easy now? Does that make sense? So the biggest question in between this is actually, is it going to be a independent or dependent? Now let's look at this next one. A shipment of 20 computers. 4 defective, 3 computers are randomly selected and tested. What's the probability that all 3 are defective? Assume no replacement. So what does that mean, no replacement? Go ahead, Carlos, what?
Huh?
What do you think that means?
Can't replace it.
Okay, am I putting Fred back?
No.
No. So I'm going to test. So this one's going to be dependent, right? That's dependent because I'm not going to put, whichever one I test, I'm not going to put it back into the pool because I don't want to test that same computer again, right? So you have to think through the problems as we do this. So let's start off with probability that all 3 are defective. So the first one's going to be, what's the first probability of getting a defective computer?
4 out
4 out
of 20.
of 20. Now, and it says all 3 are defective. So I'm going to pick another one, right? I'm going to pick another one. And so that next one would be?
Would it be 3 out of 19?
3 out of 19. Because I already picked a defective one. It says all 3 are defective. So if I pick a defective one, that means it reduces that number also. And it also reduces the pool. 3 out of 19. And my third one's going to be?
2 out of 18.
What is it?
2 out of 18.
2 out of 18. Very good. So you are calculating this in your calculator. In your calculadora. Plugging it in. Getting some answers. Hello. How are you doing?
Excellent.
You are super. Oh my
For
goodness.
Overdue books advisory.
Oh, my advisory?
Yep.
Okay, thank you. All right, we ready? So we came up with point 0.003508,
3508.
like that.
17.
Okay, and it just keeps going, right? So let's just take it to the point 0.0035. So that makes sense. So that means it's going to be, what would my percentage of this one be?
Thousands.
Okay, but as a percentage, how would I write this?
3.5%.
No.
Oh. 35. 90.
Nope. As a percentage, what would this number turn into as a percentage?
3.5.
Not 3.5.
0.3%.
0.35, because if you turn in percent, it goes over just 2 numbers. Remember, percent means out of 100. So that second place value there, the second 0 is my hundredths place. So this is a point 0.35%. So that is less than 1%, isn't it? It's less than 1% for that to happen. And that's what we're talking about in different probabilities of these. So it's not likely that's going to happen. Not saying it's impossible, saying it's not likely it's going to happen. Does that make sense now? Yes, hopefully, maybe? All right, so let's look at this next one then. In the same shipment of 20 computers, 4 defective, 3 computers randomly selected and tested. What's the probability that the first defective one is the third one? Okay. So that means, what do I want the first one to be? What do I want the first one to be? Not defective. So what would my number for not defective be?
16 out of 20.
16 out of 20. So that's what I want. So I want my third one to be defective, not my first one. So it's 16 out of 20. What about the second one? Do I want the second one to be defective? No. So my second one would be
15 out of 19.
15 out of 19. Very good. But the third one, what do I want the third one to be? Do I want that to be defective? I want that one to be defective. So what would I say for that? Say it again. So I heard the 18. What was the top?
2.
Not 2.
3.
How many are defective?
Oh, there'd be 4.
Very good. Yeah. So 4 out of 18. So we shrunk the pool, right? We shrunk the overall pool, but then right there, I still have 4 defective in that pool. All right. So you guys are calculating. Did we get it? Ready?
I got 14. 0.140.
Okay, that's good. So it's 0.140. Okay. So that's fine. And so as a decimal, or I'm sorry, as a percentage, that would be 14.0%.
I think it's 15.
You think it's 15?
Oh, no.
Why do you think it's
I
15?
messed up. You put a 5 in there.
Oh, okay. Okay. And
No, I was sleeping.
okay, is that what you got? Yep. Okay, good. Just making sure everything's all right. Any other questions? Oh, we okay on this, right? I'm hoping. All right, last one here. Last one here. Same shipment, 20 computers, 4 defective, 3 computers are randomly selected and tested. What's the probability that at least one of the computers is defective? Ooh, at least one. At least one. That one's actually going to be special. That has to go with what we're going to have. So at least one to be defective. I'm going to make it a little bit bigger here. There we go. So at least one of those two to be defective. Okay, at least one. So I'm actually doing the opposite now. So I'm going from the being defective, right, at least one. So I'm going to start off with 1 minus, okay. So I'm taking this away now. I'm taking this away from the whole thing. Yes? Does that make sense or no? 100% is my 1. So I'm going, and this is the complement for this. So we have 1 minus, so my first one, what is it not going to be? At least one of them is going to be defective. So let's see. So the first one would be what? So what's the complement to the defective? 16 out of 20. Very good. So I have 16 out of 20. So that's my complement to this. So that at least is the key word for this. And that's why I'm doing it differently. So the 1 minus all of this. All right. What's the next one going to be? And we're not replacing it either.
54,
15 out of
19.
15 out of 19. Remember, it's the complement to that. It's the complement to the defective. So it's 15 out of 19. And 14 out of, there we go, 14 out of 18. So this is the complement to it. So whenever I have the at least, I'm going to take it away from this. Yeah? Are we doing the math? What is it?
Or 0.4912.
0.4912?
Yeah. 50.
Yeah. 50 what?
Or I think I put it in.
0.508. Why are people slamming doors? Why we can't have nice things over here? You guys agree? Has everyone got this now?
Yeah.
Okay, so now, do you guys understand why I keep having you ask you to do the practice on the calculator? The little bitty things, missing number, is going to mess up your answer. I don't want you to get it wrong on the test just because you didn't put it in correctly. So that's what I'm verifying on this. So now, as a percentage, this would turn into 50.8%. Not bad? No? Okay. So, that being said, I'm hoping you guys actually feel pretty good about this. So, the biggest issue that we might have is going to be deciding if it is replacement or not replacement. Alright, like, share, and subscribe. Hit that notification button, and buy my merch store.